everyone, and then welcome back to our online class. The second is we were talking about discretization. Discretization is a data transformation technique that is used to convert a continuous variable or an attribute to a discrete one. Like yes, please, I'm getting a lot of disturbance when your audio is on, girls. Yeah, now it is fine. Or we optimize your the others are able to girls please mute your audio, Shravan. Okay, coming back, when we are talking about discretization, we will see that we are trying to convert a continuous variable or an attribute to a discrete one. Yes, right. Now, there are two ways. Why do we do this? Because there are certain classification variables which will accept only the discrete values, but not the continuous values. When we are dealing with the discretization, there are two ways to attribute or discretize the attribute. One way is unsupervised way, where the class labels do not matter, and the other one is a supervised way. Here, the supervised way, when we are talking about, the entropy comes into the picture. Entropy based is the supervised way of discretization. Now let's first define what is entropy. Okay, so yesterday we have looked into the binning. Okay, if you remember, we have done the binning. Then one second. And then we have done the histogram analysis. And then we are yet to do with the cluster analysis. Now, when we are talking about cluster algorithm, what we are doing, we are trying to group all the relevant data into clusters, or the similar ones we are picking up, and then we are trying to form into groups. We call these as clusters. Clusters basically we use in order to find out if there are any outliers. Okay, this I've made it very clear in the earlier classes too. Each cluster forms a node of concept hierarchy where all your nodes are at the same conceptual level. Now, each of this cluster may be further decomposed into subclusters, isn't it? Now, this will allow us to form a lower level of hierarchy. From the higher level of hierarchy, we are getting to the lower level of hierarchy when we are trying to decompose a bigger cluster into subclusters. Okay. Now, clusters may also be grouped together in order to form a higher level of concept hierarchy. Now, are we able to correlate these clusters to the concept hierarchy? So we say there are subclusters, and when you group the subclusters, we are making into a higher or a bigger cluster. So these bigger clusters also can be grouped to form to the higher level of concept hierarchy. Now let us get back to our discretization. Now, coming to the entropy-based discretization, as I said, this entropy-based is a supervised way of discretization. So here, entropy is the measure of randomness in a set. What do you mean by this? I am trying to check whether in a given set, what kind of values I am holding. Okay. So it is measured from the range of 0 to 1. So if a set has an entropy 0, then all the members are of similar. That is, all of them belong to the same class. When I say it is 0, it is belonging to the same class. Say, suppose all of you belong to MSc Data Science. If it is not, when I call the entire MSc group, I have chemistry, mathematics, computer science, and data science. So this entropy would be 1, where this is a complete dissimilar set. Similarities between the same group. Dissimilarities, all the different groups are clubbed together as one cluster. So this we call it as an impure set. Now you are understanding, if the entropy is 0, we call it as a pure set. If the entropy is 1, we call it as an impure set. Okay. Now here, when we come back, And if a set has an entropy 1, then all the members of the set are very dissimilar to each other and are of very different classes. So here we call it as a class set. So let us get back how exactly we need to calculate a entropy. Now, in order to find the entropy or to calculate the entropy, we have a small formula. You can just see the formula on the screen. Entropy of S and C equals to, if you're trying to say, suppose for instance, I have a set S, S set, suppose I have in that about 12 distinct values in the set S. So what I do is, based on certain intervals, I will try to partition that the main set S into S1 and S2 using some kind of a boundary. We'll work out on one small example so you will understand how to partition this and how to calculate the entropy. Please, if you're holding a pen and a paper, write down the formula that is given on the screen, girls. Okay, this one. Entropy of the set S with a boundary. Okay, T is a boundary, girl. Okay, where if you're trying to divide the intervals into S1 and S2, the S is divided into two partitions, S1 and S2. So here, S1 by your the original S, the set, and the entropy of S1. Then S2 by entropy of S2. So here, the boundary that we are trying to focus on will be the T value. Okay. Now, the boundary that minimizes the entropy function over all possible boundaries in order to boundaries is selected as a binary discretization. So, how do we get to this discretization? When we're trying to calculate, we use a is based to 2. Okay. Now, the process is recursive, as I told in the earlier class, which is applied to the partitions obtained until some stopping criteria is met. That is, when we reach that this entropy is the best one, or this is the one which is best suited for this particular set, we'll stop it. Now, as I was talking, entropy of S1. How do you calculate entropy of S1? We will just see in the next slide. So, experiment shows that you are trying to reduce the data size. Say, suppose I have 1000 sets. Then I have made an interval into 300 and 700, and I would like to find out which one is having what kind of an entropy. Okay, so are you following, girls? I'm just trying to move on to the next slide so that we'll start working out on a simple example. Okay, now before getting on to this, one second, right? Now we will take a simple example based on your entropy based discretization. Now, if you have a pen and a paper, please take it up and then write down the values. Now, I am taking a set S, okay, where I have 9 items in it, okay, 9 data items in the entire set. So here it comprises of the attribute and the value associated with the attribute. Okay. Now the attributes are 0, 4, 12, 16, 16, 18, 24, 26, and 28. For each of them, we are having some class, whether it is yes or no. We're just taking some random data set. Okay. For instance, the same, if somebody is affected with the virus, I am trying to take the age group of from 0 to 28, for instance. Okay. Now 0 is affected, yes, and that is the child is between 0 and 1. That is, he's less than 1 year old. 4-year-old, yes. 12-year-old, yes. 16-year-old, no. 16, no. So when I've taken a group of 9 people, out of which I'm trying to find out the class which they belong to. Okay. Now let's get back. You will have several kind of intervals when we discretize the values into separate bins. Now this we are trying to enforce some kind of binning. Okay. Now a probability of that, each those class appear in each of these intervals. That is, whether they're appear. If I'm trying to take from 0 to 14, for instance. Now, if S is partitioned into S1 and S2 using two possible split points. Okay, usually they'll try to give us the split points where we have to split the entire set. Now, S is split into S1 and S2. First, we'll try to take the split at 14. Okay, when we are taking a split at 14, I will be getting 0, 4 and 12. And in one set, that will be S1. Okay, another S2 will be the rest of it. So out of 9, when I'm taking 3, the rest is 6, isn't it? Now here, this first we need to sort the set. Now this set is already sorted, so I don't need to sort it further. So I'm taking S1 as the first 3 girls. That is where my split point is 14. Now the rest is 16 onwards till 28. I have six more. Okay, did you get this? Please write this down. I'm just getting back to the earlier slide. Just get this down. Before that, you please understand, I'll repeat it. There is a probability of that each of these classes appearing in each of these intervals. The interval between 0 to 14 and from 15 to 28. Okay, right. That is what we need to summate. We have to summate the sets here. So the negative of the summation is your entropy. How do you calculate this negative of entropy? I'll let you know. Okay, right. I'm moving to the next slide. All right. We're working on a simple example, girls. Okay. Now, if you're looking into the earlier one, okay, this is what we need to calculate, girls. If you remember this or if you already noted it down, I'm going to the next slide. Right. Now here, I'm taking the 14 as the split point. Okay. So how many did I get? I got 3, isn't it? 3 out of 9 set in S1 and 6 out of 9 in S2. So let us see. 3 by 9. Okay. And entropy of plus 6 by 9. If you remember, S2 is 6 and the entire set is 9. So you are trying to take the entropy of S2. I think I'm clear till here. Are you with me, girls? You can just chat. Okay, right. Yeah. Then how do I calculate entropy of S1? This will obviously be 0. Why? Because now here I have all the classes to be Y. That is Y, Y and Y. Yes, isn't it? All the yes. Then that means I do not have any dissimilar items in the set. So all are similar because all the values are same. Hence entropy is 0. Okay, now coming to the entropy of S2, how do you calculate the entropy of S2? Minus probability of Y. Okay, minus, I said minus. Why minus? Because you make a point, girls. The negative of summation is your entropy. You can write it down. The negative of summation is your entropy. Now, when I would like to calculate the entropy of S2, I'll use this simple formula. Okay, minus py log 2 py minus pn, that is n, that is no. Okay, probability of occurring no. Why am I taking log 2? Because I have only two values, binary values out here, either yes or no. Okay, then probability of no. Now let us calculate the entropy of S2, girls. Okay, now here minus 1 by 6. 1 by 6 log 2, 1 by 6. Why 1 by 6, girls? You tell me why 1 by 6. When you look into from 16 onwards till 28, I have only y value, only one y value. How many n values I have? 1, 2, 3, 4 and 5. Now you got the point? Why we have taken 1 by 6, girls? Out of 6, I have only one y value and log 2, 1 by 6 minus 5 is the n value out of 6. So you got the point. Once we calculate this, we'll get this particular value. Your mathematical students, I know you are very well in calculating. I hope I made it right there. Okay. 0.0659. Okay, right. Okay. Now, this is the value of entropy of S2. So this will try to substitute here, girls. Got it now? 3 by 9 into 0 will become 0. 6 by 9 into 0.659 will give me 0.439. Got the point now, girls? Okay. So the S1 is 0. So multiply that with anything will be 0, right? And then 0.439. So here, this will be the entropy of the set S where you had made a split point as 14. Got the point now? In order to find the information gain, we need to find the information gain given for the split point 14 and the split point 21. Now we have calculated split point 14. In order to find the information gain, we need to first find the entropy of the original set S. So let us see how do we calculate this. Now entropy of original set S, if we take, E of S is minus P of Y, okay, and then log 2 P of Y minus P of N log 2 P of N, okay. Now it is the same one which I have applied. If you remember, right here, okay, right here for S2. Now what are we doing? We are trying to calculate it for the original set S. So P of Y is what, girls? 4 by 9. P of N is equals to 5 by 9. I missed out this oblique, girls. 5 by 9. Okay. Now therefore, now entropy of S is what, girls? P probability of Y is minus 4 by 9. Log 2 4 by 9. Okay, I'm going back again. Right. Okay. Right. And then minus this 5 by 9 log 5 by 9. So here if I try to calculate the entire thing, I'm getting the entropy as 0.99. Please note this down. This is highly impure set. Why? If it is 0, it is pure set. But if it is 0.99, that's almost near to 1. So it is highly impure set. Yes or no? Are you with me? Are you with me, girls?
Yes. Yes, ma'am.
Please note down these
Yes, ma'am.
example. Please note down the example. Okay. If you are done, then I'm going to the next slide. So now, what are we doing? We have calculated the, one second. Yeah, we have calculated the entropy of this particular one. All right. So let's first find the entropy of the original set S that we have found out. What is it? 0.099. Okay. Now let us get back. Now entropy of S2, 1 by 6 log 2, 1 by 6 minus. Now we got this value, girls. The earlier slide. Yes? Okay. Now, how do I calculate the information gain of the split where the split is at t equals to 14? Now, gain of ST is calculated as entropy of the original set minus entropy of the set where you have taken the split at 14. So, the value that we have taken at 14 is 0.439. So, here we will say 0.99 minus 0.439. That is the value as 0.551. Please remember this. Okay, please remember this. This part you write down. From the information gain till here you note it down. Okay. If you are done, then I'll move to the next slide. Okay. So I'm going to the next slide. Now, if the split is at 21, girls, shall we work out? Yeah, if the split is at 21, then I'll say t equals to 21. Now, what will my sets look like? S1 I'll have, 0, 4, 12, 16, 16 and 18. That will be 1, 2, 3, 4, 5, 6 in the set 1 and 3 in the set 2. Okay. Now let us calculate the entropy of S of T, where I have taken a split at 21. So the same formula if you are trying to use, S1 by S, entropy of S1 plus S2 by S, entropy of S2. So let us calculate the entropy of S1. Now here the entropy of S1 is minus 4 by 6. Why 4, girls? P of Y is what? 1, 2, 3,
Yes,
4.
values are 4,
4
ma'am.
by 6. Log 2, 4 by 6. Then you have only 2 y value, 2 n values. So here 2 by 6 log 2 and 2 by 6. Please write it down. When you're listening, please make a note of it. So here, when you try to calculate the entire value, I'm going to get 0.927. Okay, this is quite the similar set. Yes, then entropy of S2, that's equals to 0. Why? Because you're all having the similar nodes. Okay, even if you try to calculate using this formula, you'll get 0, right? So now here let us find out entropy of S of 21 will be 0.618, if I'm not wrong, plus the entropy of S2 is what? 0, because all are similar ones, isn't it? Now, once we have calculated this particular one, that entropy of S of T, when you're taking a split at 21 is 0.618. So what I need to do, I have to later find out the gain of the set S when you have taken a split point at 21. So here it will be E of S minus E of S of T. That is equals to, we have found out the entropy of the actual set 0.99 minus 0.618. That is equals to 0.372. Okay. Now, the gain at 14 is bigger or the gain at 21 is bigger? Tell me, girls. Gain at 21 is 0.372. We'll have to see which gain is higher. Okay, which gain is higher. So here gain of the set S at the interval 21 is 0.372. But the gain of the set S at the split point of 14, it's 0.551. Okay. So here the gain is more at the split 14. So value 14 you need to take is the best split, or we can call it as optimum split. But why do we need to go for the splitting, girls? Because we are trying to reduce the size of the data sets in such a way that we would like to search in the similar kind of data sets rather than searching or banging our heads in order to find in the dissimilar sets, isn't it? What are we trying to gain? We want to gain where there is maximum or the maximum it is leading to the zero entropy rather than one entropy, isn't it? What is the zero entropy? Where you're having similar data items which are dissimilar, we are calling the entropy to be near to 1. Okay. I hope you've understood this point. Okay. Right. So before we go to the next slide, I just want you to tell me whether you all have understood this point. Yes or no?
Yes,
Yes.
ma'am.
Right.
Yes, ma'am. Understood, ma'am.
Yes, very good. Now, we'll get to the next point, the interval merging by chi-square analysis. Have you heard about the chi-square, girls? You were working on the chi-square using the statistical analysis, if I'm not wrong. Yeah, we do not have much to learn about it. We just are learning the chi-merge. Okay. Now, under the chi-merge, there is an approach called bottom-up approach. Why do we need this is we are trying to find the best neighboring intervals and merge them to form a larger interval. We've taken a simple example of age group, girls, isn't it? I said 0 to 5 and 5 to 10 age group of the children. Now I am unable to find any kind of findings from 0 to 5. I had maybe about 2 findings, but 5 to 10, I'm having about 6 or 7. So why can't I merge 0 to 5 and 5 to 10 and make it a 0 to 10 interval? Are you understanding this? You're trying to take the best neighboring intervals and merge them to form a larger interval. So this is about bottom-up approach. Then coming to the supervised method, now here entropy also is supervised kind of discretization. If two adjacent intervals have similar distribution of classes, like I have most of the time it is yes and yes only, then why can't I merge those two? I can do that, isn't it? Because both of them are belonging to the Y class, not to the no class. So I will merge all the ones which are falling under yes group, like people who have tested positive and people who have tested negative. Why do I have to? People who have tested positive, let me all merge them and keep it in one group. Okay, so they can be merged. This is a supervised way. So initially each value is in a separate interval, isn't it? It will fall under 1 to 3, 3 to 5, 5 to 6, or 5 to 7, or 7 to 10, like that, separate intervals. But later on, when you're doing some kind of a merging using this chi-square, you're trying to reduce the smaller intervals into, or you're making it to larger intervals. So the chi-square tests are performed for the adjacent intervals as well. Those with the least values are merged. Okay, this can be repeated. Okay, based on the threshold or the number of intervals. That should be your stopping condition. Now you can't go on merge all the values, isn't it? You have to stop somewhere. Yes or no? So that stopping condition should be provided to us. Okay, so that you have to take a call where you have to decide on the stopping condition, right? Okay. Now, when we get back to the chi-merge method, as I said, initially, each distinct value of a numerical attribute A is considered to be one interval, isn't it? It is 1, 1, 1, 1 like that. If I have 100 values, there are 100 intervals. Okay, that is the initial stage. When you are putting the chi-square test are performed for every pair of adjacent intervals. These adjacent intervals with the least chi-square value are merged together. Since you are having lower numbers in this particular interval. So what are you doing? You're trying to merge. So you're pairing up, indicating certain similar class distributions. This merge process proceeds recursively until a predefined stopping criteria is met. I said you have to take the stopping condition. You have to decide on where I need to stop merging. So you need to understand the significance of merging and to what level you are merging and to what can be the maximum interval that you have to consider, and the maximum inconsistency also has to be taken into consideration. So these all will be your stopping criteria or stopping condition. This is what is called your chi-merge method. Okay. Now let us get back to the segmentation by natural partitioning. What do you mean by natural partitioning? Say I have a group of elements. Either I'll try to put them into evens or odds. There is a simple 3, 4, 5 rule can be used to segment a numerical data into relatively uniform or natural intervals. Usually we say a child, we call him as a child if he's um, more than 2 years old and less than 10 years. Okay. Then we will, a young child, we call it as 10 to say suppose 13 or 14. Then we'll say 14 onwards he is an adolescent. Okay, or something like that. Okay, we will decide the intervals. If an interval covers the 3, 6, 7 or 9 distinct values at the most significant digit, partition the range into 3 equal width intervals. That is, I want to take the interval as 0 to 10, 10 to 15, 15 to 18. Got it now, right? So let me decide on the distinct variables, girls. So this we call it as 3, 4, 5 rule. Okay. Now I just took a simple examples in order to make you understand what it is. That's it. If it covers 2, 4, and 8 distinct values, I'm taking a even numbers at the most significant digit. then I'll partition the range into 4 intervals. Okay, then that is 2, 4, 6 and 8. All right. If it covers 1, 5 or 10, then the distinct values at the most significant digit, I'll partition the range into 5 intervals. Okay, based on 5, right? Okay. I think I'm just trying to check the time, girls, because abruptly this is getting ended. So I'll just go back and then review what we have done today. We have done only a small aspect, but I think it is good enough. Okay, we have talked about the entropy based discretization and we worked out on simple example. Okay, the entropy based discretization, an example on this. I hope you have followed this part of it. Okay, and then the chi-merge, or the using the chi-square analysis, how do we merge the intervals? Okay, and then the segmentation by natural partitioning. This is coming under your this. Are we done with all the 5 methods of concept hierarchy generation, girls? So are you clear with binning, histogram analysis, cluster analysis, entropy based discretization, and the data segmentation by natural partitioning? Have you all followed this, girls?
Yes, ma'am.
Yes. So I think I will stop here. I think only 14 have joined, girls. Okay. I'm 1 second. I'm stopping the